So in this quick video, I'm going to show you how to find the inverse, how to solve an exponential equation using a logarithm, and how to solve word problems using that involve exponential functions using logarithms. So first, we're going to talk about the inverse of the function for linear functions, for exponential functions, and for logarithmic functions. And you should be able to do all three to meet this standard. So the core idea of finding an inverse is to switch the x and the y value and to solve for the y again, because currently in each of these, all of them currently are solved for y. And if we switch the x and the y, then the y will be here and the x will be here, and we'll have them in reverse. And that's by definition what an inverse is. So the first thing I'm going to do on all of these is switch the x and the y. Oops, we want it to be a y plus 4. And then we're going to solve for a y. So we're going to essentially do PEMDAS backwards. So if you remember parentheses, exponents, multiplication, division, addition, and subtraction for when we're simplifying things, well, we're going to think about it going backwards. So the first thing we're going to want to do is undo subtraction. So I look for subtraction. Is there subtraction here? No. Then I want to undo addition. Well, there's addition right there, so I'm going to undo addition. So the opposite of addition is subtraction. So I subtract on both sides, and I'm left with x minus 4 equals 2/3 y. All right, and then I move on. What's the next thing? I undo division and multiplication. So undoing division and multiplication. Well, I have this multiplication by a fraction. To undo multiplication by 2/3, we're going to multiply by something called the reciprocal. And the reciprocal is multiplying by the flip, essentially. So I'm going to multiply this side by 3/2. And then I have to do the same thing to the other side. I multiply by 3/2. And the reason we multiply by 3/2 is because 3 divided by 3 is 1, and 2 divided by 2 is 1. And then we're left with just the y value. So we're left with y, and 3/2 times x minus 4. So this is our inverse for a linear function. Now it's really important to note that when I multiplied by 3/2 over here, that I did it to everything. So this is saying I'm multiplying x minus 4, both of those things, I'm multiplying that by that 2/3. All right, we'll move on to the next one. Very similar procedure. We're going to switch the x and the y, and notice that it's 10 to the power of 2x. So the 2x is in the exponent. So we're going to switch the x and the y. So x, I'm going to rewrite it a little bit further over here. X equals 10 to the power of 2y. Remember, we're switching the x and the y plus 3. And again, we're going to go back and we're going to use PEMDAS backwards, essentially. So I have to undo addition and subtraction first. So I see there's addition. So I'm undoing addition by subtracting 3 from both sides. So I'm left with x minus 3 equals 10 to the power of 2y. Okay? And at this point, x minus 3 equals 10 to the power of 2y. I'm just copying it down. Here, let's use a different color for that. I'm just copying it down. So it looks like I'm a little bit stuck. The important thing to note here is that we've got it in a format that's really nice. So we've got some number equals base to some exponent, and I'll write that down right next to it. We've got some number equals base to some exponent. And we know that we can convert that into a logarithm because it's log base b of that number is the exponent part. So when we know this piece of information, it all kind of comes back together. Because I've got my base, I've got my exponent, and I've got my number. So all I'm going to do is I'm going to rewrite it using this idea. So log base b, the base b is 10, because it's 10 to the power of 2y, of the number in this case is x minus 3, and the exponent is 2y. Now to finish this up, we need to get y all by itself, and so we've got 2 times y right here, so we're going to divide both sides by 2. Because if I'm working PEMDAS backwards, I now undo the division and multiplication. So divide both sides by 2, and we've got log 10 of, I'm going to make that a little bit smaller. Change my pen here. Got log base 10 of x minus 3 divided by 2. And that's your answer. So I'm going to highlight that just so we all know. This is our answer. A little bit small there. All right, and our last one, I'm going to use that smaller pen. It's hard to see. I'm going to rewrite it. We got y equals log base 2 of 2x plus 3, and we're trying to find the inverse. So again, we're gonna utilize this property here. And right now I've got some exponent, e, because it's the thing that's all alone, equals log base 2 of some number. The number is 2x plus 3. So I hope you see the connection between these two, this idea and what this is. So the first thing I've got to do is, because I can't really do anything other, well, I'm going to switch the x and the y first. X equals log base 2 of 2y plus 3. I'm going to just convert it into this exponent form because it's kind of locked in a log form. So I've got 2 to the power of x equals 2y plus 3. We're going to rewrite that up there. So we've got 2 to the power of x equals 2y plus 3. Now we just do PEMDAS backwards, so undo that addition and subtraction. We're going to subtract 3. Subtract 3, so we've got 2 to the power of x minus 3 equals 2y. And last but not least, get rid of the number in front of the y, divide by 2, divide by 2. Okay, and those are going to cancel out, and we're going to be left with y. So my answer is y equals 2 to the power of x minus 3 divided by 2. Answer. I know this was long. Finding an inverse can be really challenging, but the next couple pieces are a little bit more straightforward. All right, so we're using a logarithm to solve an exponential relationship with a logarithm. So I'll read you the story, and then I'll talk about how we go about doing this. So when Starbucks makes a kid's hot cocoa, the only difference is that the milk is not too hot. Manny's mom forgot to order the kids' version, and it was too hot. The perfect drinking temperature for hot cocoa is 130 degrees Fahrenheit, but the regular drink comes at 170 degrees Fahrenheit. Manny's mom writes down the following equation to determine the number of minutes she has to wait to give the cocoa to Manny. And she's using this equation. Note that the y is the temperature and the t is the passing minutes. Use the equation and the logarithms to determine the exact number of minutes Manny's mom needs to wait for her drink to be exactly 130 degrees. All right, so we've got this thing. We know that the y value is the temperature, and the t is the amount of time. It's currently 170. I see that 170 in the equation right there. This is our rate of change, and I want to know, when is it going to be, what time is it going to be when the y value is 130? And so that kind of gives us the foundation for how we set this up. So instead of y equals 170 times 0.98 to the power of t, it's going to be 130 equals 170 times 0.98 to the power of t. And at this point, all we're really doing from here is solving this equation. The key, again, is to remember that we're doing PEMDAS backwards. So when we're solving, we're going to think, how do I undo things? So I see, before I can undo this exponent, I have to undo the multiplication because I got to do multiplication before I do exponents. So to undo that multiplication, I can divide both sides by 170. Divide by 170. And I get 130 over 170 equals 0.98 to the power of t. And we're going to convert that into a logarithm because I've got the base value, I've got the exponent, and I've got the number. So we're going to convert that to a log. Log base 0.98 of 130 over 170 equals the t. Well, this is nice because we're looking for this t. We're looking for the exact number of minutes. Well, here's what I'm going to do. I'm going to put this into a calculator on my website or on our Canvas page. I've added a link to the Desmos logarithm solver. You're going to want to use that because we have this strange base of 0.98. But all you're going to do from here is put it into a calculator. And with the magic of video recording, I got 13.27 equals t. That means 13.27 minutes for the cocoa to cool. Minutes for the cocoa to cool. To cool. All right, we're going to swap to the next one. So house values go up and down all the time, but most go up in value each year, making them a good investment. Most grow at about 4%. All right, so 4% is an important number. There's a little typo in here. It really should be 5%, so my mistake. Each year, from the year before, it goes up 5%. If Gia bought a home and it was $170,500, the equation that would represent her home value on year t would be this equation, 170,500 times 1.05 to the power of t. Use the equation to find the number of years when Gia's house is exactly $200,000. Okay, so again, the y value is the value that we're interested in. We're interested in when the y value is 2,000. So our equation is 200,000 equals 170,500 times 1.05 to the power of t. We're going to divide by 170,500 on both sides. And that cancels out, so 1.05 to the power of t. We're going to leave this as 200,000 divided by 170,500 so that when we turn it into a log, we get the perfectly correct answer. So now I have this exponent. I've got a number, I've got a base, and I've got an exponent. I'm going to convert it into a log. So log base 1.05 of 200,000 divided by 170,500 equals t. And I'm going to put this into a calculator, and we're going to find out the answer. And we seem to get, when we put it into a calculator, when we put this into a calculator, we get 3.2707 equals t. And that means the years until the value is $200,000. All right, I hope this video was useful. Please pause if you're confused, and please do send me an email if you have questions. All right, our last one is rewrite and solve exponential functions using logarithms. So there's two ideas here. These first two are solving exponential functions for the x value, which is kind of what we did in the last video. These last three are about the logarithm properties, and they come up again and again. So you may want to go back to the video where I talk explicitly about the logarithm properties, because I'm going to go through them really fast here, and that video helps a little bit more. So we're going to solve the equation for x using a calculator if needed. And you will need a calculator for these. I do have the Desmos calculator on our Canvas page that will make this really easy to do. So first things first, I'm going to do PEMDAS backwards. I'm going to get rid of that 4. So I have to divide both sides by 4. So I end up with 2 to the power of negative x equals 1/64 divided by 4 ends up being something even more like smaller. It's a smaller number. It ends up being 1 over 256. Some people got the decimal. The decimal is 0.00390625. But I would rather use a fraction here because it's a little bit more straightforward. Then we use a log to convert. So it's going to be log. I'm going to use a different color. Log base 2 of 1 over 256 equals negative x. And in a calculator, you'd go and you'd submit this into the calculator, or put this into the calculator. And I'm going to do it here on mine. And I get negative 8. I get negative 8 equals negative x. Well, if negative 8 equals negative x, I could divide by negative 1, divide by negative 1, and then x equals 8. Okay, so x will equal 8 for that problem right there. Right, next one. Right now there's nothing in front of the 10, and so all I'm going to do is it's ready to move into logarithm form. So we're going to do log base 10, or you could just do log base 10 of 9,000 equals 3x. I'm going to get the x all by itself, so divide by 3, and I'm going to put that part into the calculator, and I get 1.31808 equals x. And that's a really strange number, but it is the answer to this equation. So that's what the value of x is. We could go back and check it and say, oh, is 10 to the power of 3 times 1.31808, is that equal to 3x? The answer would be yes. 3 times is that equal to 9,000? Is that equal to 9,000? And if you put this into a calculator, you would get, this is our check, you would get, 10 to the power of 3 times 1.31808 is 9,000. All right, down here, again, I'm going to go through these really quickly just so you have them, have access to them. I'm going to use one of the properties and say, oh, I know that 3 can come up as a power, so I got log of m cubed plus log of n. And then I know that if I have 2 logs being added together, then they multiply on the inside. So this is log of, and I'll do this in a different color, sorry about that, log of m cubed times n, because I have a property that says, so this is the most simplified version that we can get. Similarly, the negative, or the 2 in front can hop up and be an exponent. So this ends up being log of 100 minus log of 5 squared. Well, that's nice because we know what log of 5, we know what 5 squared is. It's 25. So log of 100 minus log of 25. And we have a property that talks about subtraction, and the subtraction property says that if I'm subtracting a log minus a log with the same base, then they divide inside. So log of 100 divided by 25. Well, I know what 100 divided by 25 is. It's just 4. So our final answer is log of 4. It's the most simple that you can get this logarithm, and it uses the properties. Finally, this last one is expanding using the logarithm properties. Now, this is just doing the same thing we did up here, but going backwards. So instead of giving you the expanded version and making you condense it or simplify it, I'm going to give you the simplified version and make you expand it back out as much as possible. With division on the inside, I know that becomes 2 logs. So I've got log of x minus log of y squared. And I also have the property that says if I have an exponent, the exponent can come right down in front. So I'm going to do that. I'm going to mark it in there as well. 2 can come in front. So now I have log of x minus 2 times log of y. And this is as expanded as it can get. All right, I know this video is long. Thanks for watching to the end. I hope this was helpful. Please email me if you have any questions.